talking mainly about something called function notation, okay? Saying, okay, we're going to ignore the x, we're just adding, subtracting, multiplying, and dividing stuff. So now what we're going to start to take a peek at is something called an inverse relation, which is, it's like an opposite, sort of like add and subtract are opposites, multiply and divide are opposites, square and square root are opposites. We're now going to look at inverses in different ways, whether that's a graph, whether that's an equation, or something like that. So like I said, this is a little heavier of a day in that there's more things to cover, but then we'll kind of roll back around to it tomorrow with more time to kind of chat about stuff. So when we try to find an inverse of something, it has its own special notation, which is r to the negative first. Now, if you think about a negative exponent, it's like the flip. It's the opposite of what we've dealt with before. And so to find the inverse, all we have to do is switch the x and y values. That's it. Literally, whether it's an equation, a graph, a table, whatever, if we switch the x and y values, we have its inverse relation. And so for something to be, though, able to do that, it has to have what's called a one-to-one relationship. So what does that mean? It means that the original relation, that could be a table, that could be an equation. It can take several different things, but in general, we call it the original problem, okay? And its inverse are functions. And we're going to get into that function part here in a little bit. One-to-one mainly is going to mean if I plug in one x, I get out one y. Okay? So that's the whole one-to-one idea. So we're going to start with the easiest ones, which are tables, because everything's really visual. And then we'll start to see if this is going to be a function or not. So here's how we figure this out. First thing, write our inverse. You're like, okay, how do I do this? I'm going to take every one of these points, and I'm literally just going to switch the x and the y around. So I'm going to have negative 2, 1. Just switch those. 4, 2. Negative 1, 3. And negative 2, 4. Like, all I got to do is list them and flip them? Yep, that's all you got to do. Now, is it a function? Well, how do I know? Let me give a little hint here. If I'm checking to see if something is a function, and it's in a table or a chart or something like this, are all and to even simplify this, you're just checking to see if all the x values in the points are different. You're like, well, wait, what? So in the original here, if all I look at are the x values, as long as they're all different, last I checked, 1, 2, 3, and 4 are all different, that's going to be a function. That's good. It passes the test. But when I go to do it for my inverse, same thing. Do any of the x values repeat? Yeah. Is the inverse a function? No. I'm just going to write below that 2 repeats, so you kind of know looking later why. And so those two answers actually gave me the answer to the last part. Is R a one-to-one No, the only way R is a 1-to-1 is if R is a yes and R -1, or my inverse, is also a yes. They're both yes, or this last answer is no every time. So that's kind of the visual way we're going to do this. And so I want you to take a moment, because number 3 is going to look different. Take number 2 for a moment. I'm going to freeze frame it here. Use number 1 to try and write out your inverse and then see what you think of the different parts if you have a function, if you have a 1-to-1 or not. Because we want to see I was going to say, check with someone next to you if you're like, I think it's yes to this. What about you? Well, no, I should be like this. And I want to just make sure that we've got everybody in the same area here. So, we'll give it a run here and see. So with this one, my original, when I look at it, once I've done my inverse, my 1 repeats for my x values. That one's not going to be a function. My inverse, though, all of my x values, once I flip them around, are different. So my inverse would be a function, but it is not 1-to-1, because again, the answer to both of these has to be yes for me to get that 1-to-1. Yes, sir. Sure. And so this last one is no different. It's just in a different format. So on this one, for instance, you're like, what is all this craziness? So here's my original. So here's what I'm going to do. I'm just going to follow the arrows. I'm going to make coordinate points because I'm more visual that way. So 0 goes to 6. So I've got 0, 6. I've got 1, 2. And I've got 11, 6. Okay, those are my originals. My inverse, of course, is just take the opposites or the inverses of all of those. Now, do I have to write them all like this? No, I could just reverse the arrows, but again, especially at the start, maybe be a little more visual. Look at my x's in the first one. Everything's different. It's looking good. I look at my x's in the second one. I'm like, uh-oh. Nope. 6 repeats, so that's a no-go. And since the answers to both of those are not yes, this answer is going to be no. So if you're given a chart, a graph, well, a chart or something like this, that's going to be the way you want to go. But that gets to be a little trickier if you have a graph, because that's a whole lot of numbers you're having to keep track of. So we need an easier way for that. So what we're going to do on these is we're going to do what's called the horizontal line test. So we use the vertical line test to see if things were a function before. If it went through more than one place, it wasn't a function. The horizontal line test is used to figure out if the inverse is a function. So again, horizontal line, side to side. And both the relation and the inverse must be a function to pass 1-to-1, which means you have to pass the horizontal line and the vertical line test to be 1-to-1. You can pass one and not the other, still be a function for that part, sort of like we were up above. And so we got to read the questions carefully because it kind of depends on how we're going to answer. So for instance, determine whether the relation represents a 1-to-1, that it passes both. So if I do my vertical line test, and again, I'm always just looking to see if my vertical line's only going through the graph in one spot each time. So this one passes the vertical line, the up and down. Now I'm going to do it this way with horizontal. And again, I'm just testing to make sure that it only goes through one point in the line for each. If it passes both, it's 1-to-1. This one passed both. First time we've had it today. Several problems in. But the next one, it's a little different of a story. So I go on my vertical, and I'm like, all right, we're doing good. Yeah, we did good there. So vertical line was a pass. That did good. Horizontal's a problem, though. Because if I do horizontal, just use this as an example, that goes through in 3 places, not just one. That's bad. So if either one is a fail, that's a no on the 1-to-1 aspect of things. So it's really similar to what we're doing with the points. It's just more of a visual way of doing it. So as we kind of keep playing, and I might save part of this for tomorrow. I'm going to see how far we get before I'm kind of like, meh. Because we like to stay at 20 or less. So we'll see how we're doing here. Okay. Oh, what if we have equations? All right. The inverse of a function, f of x, oh no, not this of x thing again, is f negative 1 of x. So here's the good news. That whole f thing is going to disappear very quickly. Because our first step is we're going to replace f of x with y. We're going to make everything y equals. That will make life easier. We're going to switch x and y. We're going to solve for y, and then we're going to label it. Okay, those same 4 steps. So I'm going to label my steps as we go, this first couple. So step 1, replace f of x with y. All right. Done. Step 2, interchange x with y. All right. So x goes where y does, and y goes where x does. That's all there is to step 2. Solve for y. Make sure it's always y. Once y is by itself, step 3 is done. And then finally, rewrite with y, replace it with f negative 1 of x. That's your inverse. And so for any of the ones that we're doing, yeah, we're definitely going to save graphing, I think, for tomorrow. Do this in pieces. So with any of these, y goes in first. X and y get switched or interchanged. We're always looking to get y by itself at that point, so we'll add 7 to both sides. Be careful, x plus 7 is not 7x, it's x plus 7. And then just replace the y with its notation. But Hardy, they're not always going to be that simple. Well, that's true. That is true. That's why we're going to deal with some of this crazy a little bit down here with these, because this gets a little funky. So let's make sure we got examples of funky as we go along here. So let's do this. Yn for f of x. X and Y swap. Oh boy. Solve for Y. Okay. Got to do what we always do here. First goal, get your Y term by itself. So this time we need a little more room. Minus the 1, get that out of the way. Whoops, I almost made that X. That is Y. Now to get rid of a fraction, you multiply by its inverse. So all I'm going to do, I wish I'd have given myself more room here. I'm going to write it over here instead. So negative 2 over 5 and 5 over negative 2, that all cancels out, at least with Y. Well, what am I doing over here? I don't mind if for what we're doing, you just leave it that way. Okay? If you want to distribute it out, you can. I may have some answer keys that do that. But if all you're being asked for is to find the inverse, that's fine. And then I'm just going to replace the Y. That was step 3. This is step 4. And we're in. So it's not going to be all, all roses here, but we should be able to figure out some of this as far as that goes. All right, this one. So the only reason these got switched was because it was me trying to get rid of this. Like when I'm to this first step in number 3, am I switching that over to with the X and the Y? I'm not. I'm just using this inverse to get rid of that fraction. Let me show you one other thing here. Another way that I know some of you have done this in the past, and I just want to make sure that you've got it as an option. Some of you have been like, can I just multiply by 5? Get that out of there, and then come over here, and you can either distribute and then just divide by negative 2, and you're like, wait a minute, that's not the same thing, but it is. Negative 5 halves times X, negative 5 halves times X, negative 5 halves times negative 1 would be positive 5 halves. Negative 5 divided by negative 2 is positive 5 halves. So you can have different forms of this. But yeah, fractions, we're still going to get rid of them the same way that we have in the past. Not really doing anything different, but we have some options. Okay. Yeah, sure. So, let's do the funkiest one we're going to see. Y goes in for f of x. X and Y switch. Now we go into solve for Y mode. So anything that does not have Y with it, and here's where life gets a little more interesting. What's the opposite of squaring something? Square root. So we're like, okay, so y equals the square root of x plus 9. Now, that's fine. That is the inverse, okay? But you're like, well, what does that mean? That just means make sure that your radical ends up being greater than 0. Again, for our purposes, I'm perfectly happy with us being here. If we can get to the inverse, Hardy's happy. We'll just leave it at that. So One more of these, one proof, we're done today. And you've survived, and I appreciate your patience. Oh boy, cube. Okay, let's do this. Oh, I didn't put my title in, did I? Almost didn't do my step 4. That wouldn't be a terrible thing either in the big picture. If this was a quiz and you got the inverse and you forgot to put f of -1 and left it as y equals, I'm not going to jump up and down and scream about that. Just as a side note. Okay. One more and we're good, and we might be good. We'll see. Yeah, sure. I think we are. We're going to cut after this one because I'm at my 20 minutes and I don't want to overdo my welcome here. So, all right. Let's switch x and y. And solve for y. Okay, let's see. Got to get that set of parentheses alone first. So I got to undo this -6. Ooh. Okay. So I can't get to the y yet. I can't even get to this -4 yet because this crazy cube's out here messing things up. How do I undo a cube? You're like, uh-oh. So we said before, if we had a squared, we undid it with a square root, right? Because remember that little 2's out here, even though I don't see it, it's like whoosh. So now, if I'm trying to wipe out a cube, how am I going to do it? With a cubed root, because they're always going to be opposites. So you're like, because that makes that all go away. So you're like, this is looking really weird. So that cube over here is gone because of the cubed root. It is over here now. And now there's only one step left to get y by itself. And that's to -4. And here's the one weird part with that. That -4 has to be outside of your radical. I'm not subtracting it from the 6. The 6 is stuck in radical jail. The 4 is not in radical jail. So we're not going to combine those. We can put them on the same side, though. So again, those are the wacky ones. We're not going to see a lot of wacky, but we'll see some. And so we make our inverse. And so that's where I'm going to cut this, which means I'm going to have to adjust the assignment, which I don't have an issue with. So let me make a note here so I know that's where we cut off. So here's what we're going to do on the practice front. I believe, and I'm going to make sure before I do this, looks like a great plan to me. That's what we're going to do. Okay, so day 1 for practice. I'm going to move this up so some of you are still writing, you can. So day 1, we are looking at 1 through 9 on page 7 here. 1 through 9. It'll cover the things that we did today, and then tomorrow we will lock in on proving inverses and graphing, and then we'll kind of see where we're at from there. So